Alright, this is part 3 of the magnet experiment. I still have normal, regular state, solid state magnets. One thing I want to point out is that these magnets are not electromagnets. It's been suggested that what you're witnessing is just a simple matter of changing electric fields or something to do with a polar flip or polar switch. None of that stuff actually applies. So what I'm going to do is I'm going to cover these magnets with tape so that you can see that they're actually magnets, and I'm going to actually label them very clearly for you to show you what is actually going on. The other experiments were done with up to 4 magnets. This time I'm going to show you the same thing using only 2 magnets. I'm going to start by writing a small number in the corner of the magnets in a relatively sequential order. This has no relevance on the actual magnets themselves. What this is doing is it's showing you that the value of the magnet is absolute. The pole of this magnet has a number 1, the pole of this magnet is number 2, the pole of this magnet is number 3, the pole of this magnet is number 4. The values of the actual poles are absolute and will not change. So the only thing will change is the actual inverse rule of opposites attracting to opposites repelling, which is what I'm trying to outline. The inverse rule as applied will allow magnetism to be opposites attracting or opposites repelling. Before I even check the magnets for their fields, I assign them a value, because we know that a force of attraction and a force of repulsion are defined not by what we call them, but by how they behave. Attract, repel. Attract, repel. So, now that I know this is a repelling force and this is an attracting force, opposites attract. So I will assign this magnet its value, B. Now I will assign the opposite values, A and B. They interact the way you would expect them to. Opposites attract, like charges repel. Opposites attract, like charges repelling. Now, the inverse rule. You can do this with any number if you decide to recreate this experiment. I'm going to use the first number. I'm going to pick one at random. I'm going to use number 3. I'm going to write over this value A. Now I'm going to find the like charge value, which is A. And I'm going to rewrite the values accordingly, B. And I'm going to rewrite a larger value, A and B, to represent the changing of the actual field. In doing this, I'm showing that now opposites will attract. Like charges will repel. This has nothing to do with polar flips, electromagnetism. These are not electric magnets. I can't push a button and change the fields from plus to minus. This is just the behavior of the quality of attractive forces and repulsive forces. Magnets do not have positive north poles and negative north poles. They're not a plus or a minus spin state. They either attract or repel. An attractive force is either a pull or a push from the source. No, I'm sorry. An attractive force is a pull or a push from the source, and a repulsive force is a pull or a push from the source. The behavior of the push and the orientation of the push is the actual key, not so much what you call them or what you assign them. Magnets, they just are what they are. They're a natural phenomenon that is beyond the bias of mankind and can be interpreted incorrectly. This is what I'm trying to suggest. This would have been more clear but my assistant wasn't able to join me today. So I want to, just make that clear. I will explain in more detail what attraction and repulsion is, but for now, just understand that magnetism is the subject of the inverse rule of attraction and repulsion. It's Paul Emerson, and that was my 2 cents.